Okay, welcome to the second video, the fourth video, which is on the second quantitative genetics tutorial, or tutorial 8. I'm not going to do the entire tutorial because the majority is either repetitive from the notes or we already discussed in the previous video. But what I am going to do is show you how to calculate your correlation and relationship and regression coefficients and your B value, which has been associated, or which you can use to associate with your narrow sense heritability from your data. In particular, I'm going to show you how you can calculate those things according to the formula that Oliver and Matthew are giving you in your exam, just so that when you get to the exam you don't freak out and not sure how to use those given formula. Okay, so first things first, questions which ask for correlation, regression, or relationship coefficients are all referring to R. Now R, as stated in the formula given in your exam, R will be equal to the variance of xy over the the standard deviation of xy over the standard deviation of x times the standard deviation of y. Okay. B, which we equate to your narrow sense heritability, that's given in the formula sheet as the standard deviation of xy over the standard deviation of xx. Now the standard deviation of xy is also called your covariance of xy. Okay, so just keep that in mind if that's how you remember it. Now these formula are given to us as follows. Standard deviation of xx is calculated as the total sum of x squared minus, now just remember this sum is only for this part of the equation here. It's not talking about the entire equation, otherwise there would be brackets. So it's the sum of x squared minus the sum of x, then square it, minus the total number of values of x. Okay, your covariance, or your standard deviation of xy, is given to you as fairly similar. It's the sum of your xy values minus the sum of x times the sum of y, all over the total number of your values. Now in this case, don't get confused and put the number of x value, make your n equal to the number of x values and y values. That's not what this question is asking, so don't make that mistake. Okay, so this is all like quite a bit for one go, but these are the equations that we're going to be using. So in a question, for example question 1, where it asks to estimate the regression coefficient between the two parameters given by the values in the sample set by the question, you're going to have a set of x values and a set of y values. Okay, so and a set of y values with all of those y values and x values. The first, you're going to have to draw a table. So let's just draw a preliminary table here. You're going to have a column with your x values. You're going to have a column with your you're going to have a column with your x squared values. You're going to have a y column with all your y values given to you in the question. I think that's actually all you'll need from that, and you'll have to do a column which is the x value times the y value. Okay, that's all you need for now. Okay, so in the notes, if you go through one of the genetic correlation lecture slides, you'll come across a cut and paste table. I think it's titled like table 23.3 or something. And it has this huge table with all these values, and it looks so complicated and like it's going to take so much time. All those values are significant, but these equations that Oliver and Matthew have given you for your exam, these formula given here, are actually they simplify all that information to make it much simpler, so you've got a simpler table to work with as well. So these are the values you're going to have to write down. Alright, so first things first, once you've written down your x values and your y values, which are given to you in the questions, you're going to calculate these and you're going to calculate these. Now make sure that this xy value, so here this xy value would be this x times this y, and it'll give you your xy, and so on and so forth. At the bottom of your table, you're going to draw a new row, and these are going to be the sums of. So you're going to add up everything in this row, and that'll give you summation x. You're going to add up everything in this row, and that'll give you summation x squared. And the same here, summation y, and the same here, summation x, y. Now have a look. You may notice we almost have everything that we need. So, in question 1, they ask you to estimate the regression coefficient between the two parameters, which means we're going to use our R value. Okay, so our R here is, they say it's equal to the covariance, which is over the standard deviations of x and y, the product of those two. Okay, we have, so to work out our covariance, we have this formula given above. Do we have all those parts of that formula? We have summation xy, yes. Summation x, yes. Summation y, yes. The number of values of xy, yes. There we go, all sorted. That's the first part of your equation done. The bottom part of your equation, the standard deviation of x and y. That is not difficult. All you have to do is put these values into your calculator, calculate your standard deviation. If you don't have your calculator, you can use the normal standard deviation formula, which is, I think it's standard deviation, which most of you should know, is your summation of x squared over n. Do we have the summation x squared? Yes, over n. Fantastic. And that's for x, and for standard deviation of y, it's going to be the same thing, just with your y values, summation y squared n. Now this may require, well, it will require you to draw another column with your y squared values to get your summation y squared, and that's okay. That's not a problem. You can do that. You can even do that before you start. So it's just those 5 columns: x, x squared, y, y squared, and x times y. Not too hard, and the rest is given to you by the formula. For question 2, it asks you to calculate B, which is or your Narasim's heritability, as they are given. So now, in this case, for the second part of that question, they asked you, you're using the same data set, and you have all the pieces of that equation given here. Is your covariance over SXX. Okay, we have our covariance. Yes, we do. What about S SXX. Do we have all those pieces? Okay, so SXX was summation x squared, yes, over summation x, square that value, and then divide by n, and that will be your SXX value, and then you use that to work out B. Not that hard. I know a lot of people are quite worried about using those formula, thinking that they might not show enough, but they should be fine.